Okay, so if you're asked to solve a logarithmic equation algebraically, first of all, I just want to let you know you can solve this on your calculator too. You can do the intersection method or the x-intercept method. Okay, so if you're doing the intersection method, we have y1 is the left-hand side, y2 is the right-hand side. Your solutions will be where those graphs intersect. Okay, or if you did the x-intercept method, you have to move everything to the left-hand side. Put that in your y1, solve for your x-intercepts. Okay, but if we're doing this algebraically, first what you want to do is rearrange the equation so that all the logs with the x's are on one side of the equation. Then you want to see if you can combine that into a single log, and then if you need to remove the logs, you can. Okay, so let's just first move that negative log x to the left-hand side. So we have log x minus 2 minus log 8, and then we're going to add log x to the left-hand side. So if I were solving by the x-intercept method, this is what you'd put in your calculator in the y1. Okay. Let's just move the logs so that they're together with the x's, sorry. So we have log x minus 2 plus log x. And now I'm going to move this log 8 to the other side. So we reviewed the laws of logs yesterday. If you have logarithms with the same base, what can you do with the arguments? Add them. Okay, so, or no, multiply them. You're adding the logs, so you multiply the arguments. I was just saying what you said, but that's not right. Okay, we gotta multiply this. So now we have log, base 10, x minus 2 times x equals log 8. So one strategy you can use, say if you have exponential form, is you can actually add logs to both sides of the equation. And equally, that same strategy, you can do the opposite. You can remove the logs. Okay, so this is a little sneaky step. Remove the logs. Okay, and now we get x minus 2 times x equals 8. And we simply have a quadratic equation that we're going to solve now. So expanding the left-hand side, x times x is x squared. X times negative 2 is negative 2x. Okay, and I'm going to subtract this 8 to the left-hand side. So I have a quadratic equation, x squared minus 2x minus 8, which I can then factor and solve. Okay, two numbers that multiply to negative 8, but add to a negative 2. Yeah, negative 4 and positive 2. So from our factors, x equals 4 and x equals negative 2. What is the extraneous solution? Negative 2. You cannot have a negative log. Okay, so negative 2 would not be a solution, but x equals 4 would be a solution. And you can always verify your solutions by subbing them back into the equation. If this was a multiple choice question on your diploma or final exam, you're given a list of options, A, B, C, or D, if it's multiple choice. And if you forget a strategy, one strategy is to take the answers and sub them in for x. Make sure that left-hand side equals right-hand side. That's the way we verify our answers. That's the way you could verify any of the multiple choice solutions as well. Okay? If this was a numerical response, obviously you'd have to go through the process of solving either algebraically or graphically. Then you could check that value, make sure left-hand side equals right-hand side. Okay, so a few different ways of getting around a question like this. All right, now we're going to apply our knowledge of exponents and logs to application questions. So types of application questions that you might see regarding exponents and logs, okay, would be growth questions or decay. Okay, a times b to the power of t over p. Okay, or we could have money questions. Y is equal to the principal amount times 1 plus the interest rate to the power of the number of years. One thing that I changed on the formula sheet that will not be on your formula sheet on the final or your diploma is to divide by the number of compound periods. Okay, so I say that n is the number of compound periods and t is the number of years. So always remember to change the formula. P times 1 plus I, interest rate, divided by number of compound periods, all to the power of number of compound periods times number of years, t years. A little bit bigger? Okay, I'm actually going to change that y to an a as well, because that's the final amount. Equals p times 1 plus interest rate over number of compound periods to the power of number of compound periods times t years. I'm trying to find that page for you quick too. You want that formula? On page 244 in your text, questions like this. Okay, we also looked at half-life or doubling period, tripling period questions. We're going to start off with that. Okay, so the half-life of phosphorus 32 is 14.3 days. The length of time that it will take for 96.2 grams to decay to 12.5 grams to the nearest day is what? Okay, so which formula am I going to use? This one or this one? First one. Okay, so I'm actually going to write it out differently. I'm going to write it out as A equals A0 times C to the power of T over P. A0 is the amount at 0 time. C would be your growth or decay factor. Okay, T is the time that it takes to get to this final amount. And P is the period for the half-life, the tripling life, etc.
Which formula is on our formula sheet for the diploma?
I'll just double check that. I believe it's that first one. None of the above. The only one given on your formula sheet is the finance one.
So we need to memorize the half-life formula?
Yeah. I'm not seeing that on there. Oh. Sorry, yes, you will be given that. Okay, you'll be given these two. I was just in my workbook, for some reason it's not on there. Okay, but you will be given these two. So best thing you want to do, just like if you're in physics, is you want to go through what you know, what you don't know, and then solve for that unknown. Okay, so what is your original amount?
96.2.
Okay, the length of time that it will take 96.2 grams to decay to, so our original amount is 96.2. Okay, the amount that it decays to was 12.5. If we're talking about half-life, then what is your C value? It's 1/2. Okay, and then it's telling us that the half-life is 14.3. That's the period for the half-life. So P is equal to 14.3. T is our unknown. So any application question like this, make sure you write out what you know, then plug it into the formula. Okay, so what we know, our amount is 12.5. Our initial amount was 96.2. Half-life to the power of our unknown T over 14.3 period of the half-life. So first step is we need to isolate that exponent, so we've got to divide by the 96.2. Actually, before we solve this algebraically, can you solve this on your calculator? Absolutely. Intersection method or x-intercept method every time. So this could be y1, this could be y2. find the intersection point, that's your solution. Okay? Or move everything to the left-hand side, find the x-intercept, that's your solution. So you can always solve these on your calculator. Algebraically, however, you would have to first divide by 96.2. So we have 12.5 over 96.2 equals 1/2 to the power of t over 14.3. Our unknown is in the exponent. We cannot solve for it using exponential form, so you have to convert to log form. So that's going to be our next step. We're going to convert this to logs. What is your base? 1/2. Okay, it's always the value that has an exponent on it. Okay, your base is 1/2. So we have log base 1/2. Okay, your argument will be 12.5 over 96.2. And that will be equal to t over 14.3, your exponent. Question?
What's the a of 0 value again?
That's always the initial amount, what you're starting at.
Wait, and what's the a stand for?
A stands for the amount that we had at a specific time. And we're just trying to find that specific time. Alright, so now we have it in terms of logs. Depending on your calculator, you could probably plug this in right now, or you'd have to do change of base. Log of the argument, log 12.5 over 96.2, divided by log 1/2. That equals t over 14.3. What do I have to do with the 14.3? Multiply it. So I'm just going to put that out front. And now our t is equal to 14.3 times log, in brackets, 12.5 over 96.2. Close the bracket. Divided by log 1/2. Okay, why don't you guys all practice trying to calculate that? And I will give you the answer. It's 42.1. So we would just say 42 days. Because they're asking to the nearest day. Did anyone try and solve this on their calculator?
Yeah, I got 42.1.
Perfect. Yeah, and then just round it to 42, because they want the nearest day. Did anyone try graphically to solve it? Basically, you're going to get a graph that has a decay. Okay, this is an exponential graph that's decaying. If we set that as our y1 and our y2 as the 12.5, basically you're finding that intersection point, and you should get 42.1 as that x-coordinate if we round to the nearest day, 42 days. Okay, so I just wanted to give you a visual on that as well. Does anyone want me to walk through how to put this in our calculator and use the intersection method? Is that pretty straight? Yeah? Okay. Alright, so I'm just going to go back to this first step here, okay, Ewan? Where we had 12.5 is equal to 96.2 times 1/2 power of t over 14.3. Can I erase this? Yeah. Alright, so y1 will be 12.5. And y2 will be the 96.2 times 1/2 to the power of, I'm just going to put in brackets, x over 14.3. Okay, and we already know the answer was 42, right?
Yeah.
So on my regular window settings, if I graph this, I'm not going to see this solution. So just make sure if you're not seeing a graph, you change your window settings. Let's put it to 50 because we already know. And then also, think about your y max, right? Like your y1 was at 12.5, but it's only showing up to 10. So we have to increase our y max as well. I'm just gonna put it to 20. Okay, there's my 12.5, y1, and there's my y2 coming in. If you want to get a bigger picture, expand your window settings a little bit more. Now we just need to find the intersection point. Okay, so you're going to go second trace, number 5, and then move your cursor over to that intersection point. And then enter on the enter. Okay, 42.1. Round it to the nearest day, 42 days. Okay, so a lot of these questions that we're going to be doing from now on, you can use that method. Okay, so I probably won't go through it every time, but just want you to know. All right. Next money, it's dealing with financial applications of exponents and logs. So if a student's summer job savings of $3,000 is invested at 12% per year compounded monthly, how many months will it take to earn at least $600 in interest? Okay, I just want to make sure you guys have the formula memorized. Okay, what would I use for financial application of exponents and logs?
I over N.
What's the first letter?
Y.
A. A stands for the final amount. What does P stand for? Crickets. Principal. It's the it's the original amount that you start with. Okay, so in this case, 3,000. Yeah. Okay, and then it's 100% of what we have, so 1, plus the interest rate in this case, is it 12 or 0.12? Good, you take the decimal version. Okay, divided by the number of compound periods. If we're compounding monthly, how many compound periods? 12. To the power of n times t years. Okay, in this case, sorry, months. Okay, so a is equal to p times 1 plus I over n to the power of nt. So let's write out what we know. Our amount goes to what?
3,000?
Nope.
No, that's what I'm looking for.
Let's read through the question again.
600.
No, he's earning money. He's investing.
That's what, isn't it A value? That's what we're looking for.
No, A is known, but it's hidden. Okay, if a student's summer job savings of $3,000 is invested, blah, 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 how many months will it take for him to earn at least $600 in interest?
Oh, so 3,600.
Exactly, you gotta add this 600 to the 3,000. You guys, eventually. All right, what's your principal that you're investing? 3,000. Okay, interest rate will be the decimal, 0.12. Number of compound periods, 12. T is unknown.
Are we always going to be looking for T?
Not always. Yeah. Sometimes they might ask you to solve for the principal amount or the number of compound periods. Yeah, it can vary. The reason why I'm guessing you'll probably see a question where you're solving for t is because you have to change from exponential form to log form. In the other cases, you wouldn't necessarily have to do that. Okay, so let's sub in what we know. Our A is 3,600, our P is 3,000. Okay, we have 1 plus 0.12 over 12 to the power of 12t. So first you're going to divide by that 3,000. You end up with 1.2. Okay, and then we have 1.01 to the power of 12t. Okay, so just cleaning things up a little bit. Okay, again, our unknown is in the exponent, so I have to change to log form. So I'll have log of my base, 1.01, of my argument, 1.2, equals 12t. So to calculate this, it's going to be log 1.2 divided by log 1.01 If it equals 12t, what can I do with that 12? To calculate it, it might be even easier just to like first figure out what this is and then just divide that by 12. Okay, so in your calculator, it would look like this. Sometimes they might ask you which answer would represent the answer, or like if it's a multiple choice question, and you would have to know the 12 goes in the denominator. Okay, so t is going to be equal to log 1.2 over log 1.01, also divided by 12. So t equals what?
1.532.
Oh. Okay, now one thing that's really important about financial questions is the t is always in years. Okay, very important. This solution is in years. They want to know how many months.
And so doesn't that kind of defeat the purpose of dividing by 12?
No, that's basically how the calculation of the interest is occurring
So it's
monthly.
still 18 months though?
So it's going to be 1.52 years, but then you have to multiply by 12 to figure out the number of months
But then we
it
just
took.
divide by
Pardon?
Then we just divide.
Oh, sorry, I thought you meant in the initial step.
Because it was 12t.
Dividing by 12.
Absolutely. Yes, you're bang on. Okay, sorry, Shui, I thought you were talking about the 12 here,
No.
not here. Yeah, I guess we could undo that 12. But guys, say for example that wasn't 12 there. I just wanted to show you if you end up with years, you have to multiply by 12 to get the months. Okay, so do you guys mind helping me out? What do we get there in months?
18.32.
Okay, 18.2. Oh. Did you guys round your answer?
No.
Okay. It doesn't really matter anyways. Okay, so this is in months. Now, if we have to round to say the nearest month, because this could be a question you get, at 18 months, has he saved 3,600?
No.
So at 19 months, he would have saved. So in this case, you have to round up. Now, if they word it as round your answer to the nearest month, then you would just say 18 months, okay? But if they say in how many months, then you would have to round up. So just be careful with the wording, okay? If they say to the nearest month, then you just say 18. I know that's annoying, but you just have to be really careful. Okay, let's look at the next one. How many years will it take for the value of a robotic technology, which initially cost $575,000, to depreciate to $25,000 if it depreciates at a rate of 25% per year? Okay, so sorry this was cut off a little bit. 575,000, 3 zeros are over here. So let's write out what we know. Okay. It's a depreciation question, so I'm going to use this formula. Now, is there a half-life? Is there a doubling period? No. So in this case, we don't actually have T over P. It's just going to be time.
Wait, how come we don't use that first formula that we used in question 8?
We did.
No, how come? No.
Like y equals AB to the power of T over P?
No, how come in 9 we don't use the formula we used in 8? That A equals P, bracket 1 plus I over N.
So in this case, it's not looking at an interest rate. Whenever you have interest involved, that's when you're going to use this formula. But in this case, it's looking at a depreciation or an appreciation where there isn't interest. It's not telling you anything about that. So when there's no clues about interest or having to solve for it, or they're not telling you the interest rate, you don't use this formula, you use this one. Okay? So let's go through what we know. Initial amount, 575,000. Final amount, 25,000. Okay, if it's depreciating by 25%, your C value will be 75% of what it was before. So it's basically 100%, and it's depreciating, so you're subtracting 25%. So the growth factor is 0.75. If your growth factor is a decimal, 0 point something, it's a depreciation. If it's 1.5 or 2 or 6 or whatever, anything over 1, that's an appreciation. But when it's between 0 and 1, the growth will be decaying. Okay, that's going to be the shape of the graph. What else do we know? Nothing. So we're solving for t. How many years will it take for the value of the robotic technology to depreciate if it depreciates at 25%? So we'll sub in what we know. Okay, the amount is 25,000. Initial amount, 575,000 times 0.75 to the power of t. We've done a few examples like this now. Do you think we need to go through the process of reviewing how to change this to a log and then solve for t? No. The only thing that I wanted to show you was the setup, okay? So when you're seeing different application questions, how do you set those up? So if you did want to further solve, t equals 10.89, and you'd round to 11 years. All right, next question is dealing with pH. So the acidity and the alkalinity, or how alkaline a solution might be. You've probably heard of acids and bases. Bases are also called alkaline. Did you guys learn that in chem? Yeah? Okay, good. All right, the pH of a solution is given by this formula. If the pH of pure water is 7, then what is the pH of a solution that is 20 times more acidic than pure water? Just so you guys know, this formula can be useful only if they're asking about the hydrogen ion concentration. In this question, they're asking nothing about the hydrogen ion concentration, so we don't even need that formula. It's just information, okay? Bonus information. But if we want to solve for the pH of a solution that is 20 times more acidic than pure water, basically the way pH or earthquakes or sound waves are measured, they differ by multiples of 10. Okay, so the way we're going to set this up is basically the intensity would equal 10 of one pH divided by 10 of the other pH. Maybe I'll put pH 1, pH 2. So if I use my exponent laws, then the intensity would be equal to 10 to the power of pH 1, and if I'm dividing by the same base, I subtract the exponents. So I'm minusing pH 2. Alright, so the intensity was given as 20 times as strong. So we have to think about pure water is 7. The intensity of the acidity is 20 times as strong. You have to think about, is acidic solutions going to be lower on the pH scale or higher? Lower. So that means that the number we end up with, if it's 20 times more acidic, it has to be lower than 7. Okay, so you always want to think about that scale and where it would fall. If you end up with a number that is bigger than 7, then you went the wrong way. So what my point is, how do you know when to go 7 minus x or x minus 7? You could just solve it, and if your value ends up smaller, you went in the right direction because it's more acidic. Okay, so to solve this, we have to put this into logs now. So we have log base 10 argument 20 equals 7 minus x. Question? Okay, we'll carry on. If it comes to you, let me know. So, log base 10, do I have to put log 20 divided by log 10? No, it's automatically assumed by your calculator. So you're going to go log 20. If we're solving for x, basically x will equal 7 minus log 20. Okay, and because we're subtracting from 7, we will end up with a smaller value than 7. So what do we end up with?
5.7.
Okay. It doesn't say, sorry, I didn't put what to round to. Just be careful whatever it asks you to round to. You're specific with that. Okay, so the unknown pH of the solution would be 5.7. Pardon? So in the applications section, the very last lesson of exponents and logs, basically earthquakes, looking at the Richter scale, earthquakes. There's also like sound waves. Everything is measured by a difference of 10. For example, like an earthquake, if it was a magnitude of 3 versus a magnitude of 4, they differ by 10. But if there was an earthquake of 3 and an earthquake of 5, they differ by 10 squared, which is 100. Okay? The same thing happens for pHs. So what I'd recommend doing is actually go back to that lesson if you can. I'll just let you guys know what page that's on. Starting on page 269, that's where it starts for that lesson. Okay, so it wouldn't hurt just flipping through that one more time. Typically there is one question that deals with intensities on your diploma. Every diploma I've seen anyways. Alright, so that's it for exponents and logs.